Welcome back. Next parent function is the absolute value. Now, most students that I know, and most people I know for that matter, kind of scratch their chin a little bit going, what in the world is an absolute value? Not quite sure I remember this one. But if you remember, absolute value is kind of like your happy box. Everything that goes in always comes out positive. Okay, we will explore that more in the absolute value unit. But some examples of absolute value functions in the real world are actually tolerances. And you're going, well, I tolerate a lot of things in life, but that doesn't make me an absolute value. No, we're not talking about that. I'm talking about making things fit. So a tolerance, for example, would be a screw. You can go to the store and buy that screw, and you'll know that the threads for that screw, if they say it's a certain measurement, that it's always going to be there. Well, I hate to break it to you, but it's not always perfect. It might be a little bit off one way or the other. And that little bit that it's off is called a tolerance. So in absolute values, we're dealing with the measurements. How off is it? Is it a little bit above or a little bit below? And so we look at what we call tolerances with that. Parent function equation is y equals, and then there's two vertical bars. Two vertical bars. That means take the absolute value. Whatever number we plug in, boom, always comes out positive. That's the cool part. So in our table, if I plug in -2, guess what we're going to get? +2. It always comes out positive. -1, boom, happy machine works. +1. 0, well, 0 is kind of weird because it's not positive and it's not negative. It's just 0. And people say, well, is that possible? Well, yeah, you can have no money and that may or may not make you happy. So it's a 0. It just is what it is. +1, well, positives always come out positive anyway. It doesn't matter what number I plug in, the sign will always be positive. So you may be thinking, Mrs. Boots, this is looking just a little bit like a quadratic, right? It goes down and comes back up. But the quadratic, remember, was a U shape. Absolute value is not a U shape. Watch. So -2 is +2. -2, +2. First point. -1, +1. Second point. 0, 0, 1, 1, 2, 2. This looks like a linear that somebody broke in half. Somebody took the bottom half of my linear and broke it and pointed it up. Notice the shape of the graph is a V shape. So absolute value is a V-shaped graph. So it gives us a hint in the name. It has a V shape. Okay, so this is kind of corny. I know I'm weird. I'm a math teacher, right? But it's corny. If you drop the X down inside the V and it breaks the V apart, I now have two vertical bars. And that gives me my equation. So the X broke apart my V and it gave me the two vertical bars. Kind of cool. Okay, let's look at domain. How far to the left does it go? Yep, it goes to infinity. So we've got our -infinity. How far to the right does it go? Positive infinity, right? It's going to keep going. Exact same domain as the quadratic. Also as the linear. Okay, so we have some commonality there. Let's look at the range. How low does it go? We got to look at the bottom. Well, it's not -infinity. Up, it's 0. So is that 0 included? Well, yes, it is. It's in our table, of course. So we're going to have a square bracket with that 0. And then, how high does it go? It goes to positive infinity. So that is our domain and our range. Now, did you notice something? I noticed something. This domain and range, if I look back, is the exact same domain and range for which other parent function? You got it. It's the quadratic. The quadratic has the exact same domain and range as the absolute value. It's only the top half of the graph. So we will explore absolute values in the absolute value unit, and we will learn a lot more about them. Until then, let's enjoy the next parent function.